Thank you. Welcome to today's session. Today's session will focus on the virtual maths camp playing cards. And before we begin, I will introduce myself. I am Samuel Okoth Ogalo. I'm an educator with African Maths Initiative in Kenya. And I'm excited to join here as we share this learning opportunities together. I will welcome my other colleagues to introduce themselves even before we continue.
Hello everyone, my name is Adinda Fleria. I'm a mathematics educator with African Maths Initiative here in Kenya. And today we are going to learn about the introduction to virtual maths camp card decks. And it's going to be an interactive session. So you're welcome. Thank you.
Thank you.
Zach can introduce himself.
Yep.
Yes, thank you. My name is Zach Mbasu. I am based in Nairobi, Kenya, and work with the African Maths Initiative. I'm excited to be here to learn together with everyone who has joined. I'm looking forward to participating in the session. Thank you.
Thank you. So we'll just have an introduction or a brief look at what the virtual maths camp playing cards are, and then we'll go straight to our today's activity. So the virtual maths camp playing cards is an idea for, that is supported by a few organizations that supports maths camps across Africa. And this is an idea of being able to create an activities that can be run by seasonal campers or people who attend the camps regularly. The materials were created in such a way that they can be available in card decks, printed or online, as well as a version that can be accessed in a chatbot in the social media. So the aim is to provide mathematics education that is distributable within an accessible package. So we hope that you enjoy this package that has the activities. Now the card decks are 54 in number, that with every card featuring a single activity, a unique activity from games, puzzles, and fun mathematical facts. Out of the 54 cards, 2 cards are jokers, just like a typical card deck, and the rest of the 52 cards have activities. So the activities, like I said before, enable a large variety of use with the activities that are available, with the options that they can be used either virtually or in person, without requirements of any kind of support. Now, the card decks that we are about to introduce here can also be accessed both digitally and non-digitally. So digitally, they can be accessed in the Virtual Maths Camp website. We are going to share the link. And non-digitally, they can be accessed from a printed deck with an accompanying booklet. Digitally, they can also be accessed by, so the cards look like the ones that are shown at the edges of this presentation. They have QR codes. The QR codes can be scanned and it leads you to an explanation in the Virtual Maths Camp website. So the decks are organized into 4 suites: clubs and diamonds. So the clubs and diamonds contain puzzles, counting based and non-counting based puzzles. So the counting based puzzles are found in the clubs. The clubs have this kind of a sign, the one represented by ace of clubs here. And the diamonds have this kind of a sign, the one represented by 2 of diamonds here. And the further content in the puzzles include the hints, solution, and extension puzzles. So this is an example of some of the activities in the card decks. And the hearts contain fun mathematical facts with further content on explanations and other extensions. So the hearts, they have this kind of sign that I shown in the J of hearts here. And then the 4th suite is spades. So the spades are games that contain basic rules, and these are mostly games that involve games that involve some of them involve the use of cards and without the use of cards. So they also contain further content with rules, strategy tips, and variants. So the virtual maths camp website that can be accessed using this link, the same link that we are going to share in the chat, and the booklet which can be accessed through this link is a way of accessing these activities online. And the activities can also be printed and can be accessed as well in a printed deck. Now, the virtual maths camp chatbot is currently available in Telegram. So if you go to Telegram, if you have a Telegram is a social media messaging app. If you go to Telegram and type @virtual maths camp, @virtual_maths camp _bot, like it is shown here, you will be able to access the activities in the virtual maths camp card decks by just typing the activity that you want. It will direct you. It's kind of a self-service. It asks you the questions and you answer according to what you would like to access. So thank you, and I'm going to welcome our presenter for today's session, Ms. Fleria.
Thank you, Sam, for such a wonderful introduction. Just share my screen. Thank you so much. So before we start, I would like each one of you to grab a pen and a piece of paper, because today's session is going to be interactive one, and you're going to calculate and observe. We're going to do more of observation and a little bit of calculating. So we are going to learn about mathematical thinking on counting squares. This is an activity that focuses on numbers, patterns, shapes, and addition. And here are the objectives of the session: to introduce the concept of counting and finding the pattern, learn out how to partition a square grid of any given size by partitioning shapes with rows and columns, and also how to come up with the formula for the count of square in a grid of any given size. And here is the so this is the activity. This is a square grid. So I would like each one of you to observe the square grid that is being observed. And before I continue, are you all able to see my screen? Just unmute
Yes, we can
yourself
see
and
your
say
screen.
yes. Yes, sorry. Thank you. Good. So what do you see? What do you see? Anyone? Anyone? With the response, what do you see? You can type your response in the chat. And also if you are able to talk, just unmute yourself and talk. So what do you see? Anyone with the response? Anyone? What do you see? How many boxes do we have in the upper row? And how many boxes do we have in the first column? There are some responses here. I can see squares. Thank you. Columns and rows. Good. Thank you so much. Anyone? That is from Zach Mbasu.
You can just respond by typing or unmuting yourself.
Unmuting yourself and saying, good.
Any kind of observation, any kind of
10
observation.
rows. Nice, good. An observation, what do you see? How many squares do we have in the upper row and in the first column? Good, Zach is saying in the upper row we are having 10 rows, good. Anyone with observations, anyone? Just go on and unmute yourself and talk. Any response apart from Zach? Good. So far we are just having Zach. Zach, could you please unmute yourself and give us the explanation to your answer? You say that you're having 10 rows and also you're saying columns and rows.
Yes, so what I can see is a set of squares, and on the top row, like there are 10 squares. And then on the first column, I also counted up to 10.
Oh, good. Thank you, Zach. Zach is saying that you are having, in the first row, we are having 10 rows, and in the first column, you also counted and we got there 10. Good, thank you so much. Another person with observation? Another person with observation? So how many squares do we have? How many squares do we have? Go on and unmute yourself. Just say the number of squares that you are able to see, or the ones that you are able to count. How many squares? How many squares do we have?
Hi, Tumaini. There is one of the participants who have just joined us. Hi, Tumaini, can you hear me?
Tumaini had joined earlier.
Yeah, I can see. Can you hear me? How many squares do you think are there in the grid that we have here? And what do you notice? How many squares do you think we have here?
Just unmute yourself, or you can type in the chat.
Abel just joined.
Yeah, Abel.
Hi,
Welcome,
Abel.
Abel.
We are continuing with today's activity. If you look at your screen, you'll be able to see some boxes, or just let us know what you are able to observe. And what do you think? How many squares do you think are there in your screen? What is presented in your screen?
Well, good. We have a response from Zach in the chat. He's saying that there are 100 squares in total. Good. Thank you. Another person with a different observation, with the same observation? How many squares do we have? You can go on and count. You can also unmute yourself and talk.
Well, Zach has changed his mind. He's noticing an extra square.
Okay, 101 squares. Good.
Who
okay.
else notices something else that is
Something
different,
else?
that is contrary to what has been observed before?
An observation. Abel, how many squares?
100.
Good, thank you.
Abel is saying
100. Yeah.
Zach changed his mind to 101. So we have two different answers.
Two different answers. Good. Another person with different answer or the same answer? Anyone? The different observation? Anyone?
I think there are a lot more, a lot more than 100, because I think there are 100 small squares and then one very big square, and then many other squares, such as showing 4 squares and 16 squares, etc.
Wow, thank you, Janet. Janet is saying that there are a lot more than 100 squares. Oh.
This is now getting fantastic. Now, we have different answers.
Different answers. 3 different answers.
Now, how do you know that you've counted all of them, so that you don't just conclude that there are 100 or
there are 100
or there are
more than
100
or 101? Anyone? Abel?
We just count on the width, they are 10, and going down, they are 10. So once you multiply, you get 100.
Wow, good. Abel is saying that to be sure that you've counted all the squares, you just take the upper squares, which are 10, and the other ones on the column, which are 10, then you multiply, then you get 100 squares. Good, thank you. Another person to give us explanation? Yes, maybe Zach.
Hi, Abel. Hi, Abel. Janet has just said that they might be more than 100. Janet has just said that they might be more than 100. So, do you think she is right, or do you think by taking 10 and 10 we will have counted all the squares?
All the squares.
Yes, we have counted all.
Okay, good.
By taking 10 times 10.
Okay, nice one. Interesting.
What if we don't just say 10 by 10? What if we count a square at a time?
A square at a time?
Yeah.
Yeah. What do you think?
Of course, you can get the exact answer, although it takes time.
So you're saying that there are more than 100? When we count one square at a time, a square but at a time, a square at a time.
Yeah.
Do you think we will still have 100 if we count one at a time?
We'll have 100.
We still have 100.
Yeah.
Okay. Interesting. Yes, Zach, can you explain how you are able to get 101 squares?
Yes, so I counted the smaller ones.
Yeah.
One by one up to the end, and I got 100.
Yep.
And then the biggest, because it's 10 by 10, so it has the same length and same width. So I added those to give me 101.
Oh, good, thank you. So Zach is saying that he counted the smaller squares one by one, and they were 100, and the biggest square, which is 10 by 10, and it was 1. So he added 100 plus 1 to get 101 squares.
We have another response of 100 squares from the group.
Yes.
We have someone responding from the group that there is 100 squares.
Who is it, please?
The username is Sendeo.
Sendeo, are you able to talk? Unmute yourself and tell us how you're able to get 100 squares, please.
Or maybe they are not able to join us virtually. I'll just reach him.
Oh, it's okay, good. Good. Janet had another idea of calculating squares. Maybe if you can give us the explanation on how you are able to count the squares, or your idea of counting the number of squares in this square grid. Please.
Okay, so
Yep.
yes, 10 by 10 is 100.
Yep.
And then, so those are the small squares. Then there is one big square that is, say, 10 centimeters by 10 centimeters. But then there are smaller squares that are, say, 2 centimeters by 2 centimeters. So there are many of those.
Okay, good. So Janet is saying that there's a bigger square, which is 10 by 10, and also smaller squares that there's 100. And also she went on and break to 2 by 2, as she goes on to 3 by 3. Good, thank you so much. So she's giving us that the answer is not 100 or 101, but there is 100 plus squares in this square grid. Anyone who agrees with Janet? Anyone who agrees with Janet? There is more than 100 squares in this square grid. Anyone?
Seems like Janet has a unique way of doing this that maybe we might want to look at
as we continue. Okay, thank you. So what kind of a square grid is this one? Anyone with idea? Anyone with an idea? What kind of a square grid is this one? What kind of a square grid is this?
Is it a 1 by 1?
By observing the one that it's on the screen right now. So what kind of a square grid? Okay, what name can we give to this square grid?
One centimeter square?
Good. 1 centimeter squared. Anyone? Any person with a different name for the square grid that we have right now?
$10 by 10?
Good. 10 by 10, good. 10 by 10 square grid, good. Thank you, Janet. Any other person with a different idea, the name that you can give to this square grid? Any person? Let me see. Tumaini. What name can we give to this square grid? The one that we are viewing now. What name can we give to this one? The name that you can give to this square grid? Do you have idea on what name to give it? Okay, we have HP 15. Can you give us the name to the square grid?
I think actually we have
Sorry?
100 full square.
Uh-huh.
We have 100 full square.
Yes.
Because you can count, you can take 10 by 10.
Okay, thank you. So you're saying it is 10 by 10 square?
Yeah, we have vertical scale, we have 10. And the horizontal, we have also 10.
Okay.
So after, to me, I see that the full square is the same. It has the same size. That's why I can say it has only 100 full square.
Oh, good, thank you. So you're just giving us the total number of squares. And you also say it's a 10 by 10 square. So you're saying it's a total of 100 squares. Thank you so much. Okay. So maybe Janet, you can give us the reason why you're saying it's 10 by 10 square, please, before you continue.
Because there are 10 small squares across and 10 small squares down.
Good, thank you so much. So it's a 10 by 10 square grid. Thank you. As we've seen, as you all have seen, it might be difficult to count the number of squares in this 10 by 10 square grid. So what if we reduce the number of squares to, let's say, maybe 5 by 5? What if we reduce it to this square grid that you are having here? So how many squares do we have in total?
We have 25.
25.
Yeah, because you can take 5 times 5. Because that square is the same size. That is why you take 5 times 5. But if it has different size, we cannot take 5 times 5. So for this one, because it has 5, horizontal 5 and the vertical 5, you can see we have the total number is 25.
Wow, thank you so much. Thank you so much for that good, wonderful explanation. He's saying that you're having the total of 25 squares because you're having 5 squares in the upper and also 5 squares across. Thank you. Another person with a different response? How many squares do we have? Yeah?
I think there are more than 25. So there are 25 small ones, and then one big one, and then more in between ones.
Good. So Janet is saying that she's saying more than 25 squares because she's saying that we are having 25 small ones, one bigger one, and more in between. So there are more than 25 squares. Thank you so much, Janet. Another person?
I have a question to Janet.
Yes.
How do you know the square which are in between, which is bigger than others?
Yes, Janet.
That is a difficult question, and I haven't worked it out yet. But there are some that are 2 by 2, can you, I'm trying to start drawing this on a piece of paper. And so if I drew round 2 by 2, there will be 1, 2, 3, 4, 5, 6. I can draw round 2 by 2 in different places. Maybe somebody can demonstrate this on the screen because it's difficult to explain.
Janet.
Thank you so much, Janet. Janet is giving us the explanation to her answer that she can break these 5 by 5 squares into smaller squares, let's say 1 by 1, and count 2 by 2 and count the squares, 3 by 3, count squares, 4 by 4, count the squares, and also 5 by 5 and add them together. So she's saying that the answer is 25 more squares. So the answer is not 25. There are more than 25 squares in 5 by 5 squares. Good. Thank you so much. Another person with a different observation.
Someone asked a question if
Yes.
how you would know the other squares. I think I have a question that is related to that.
Yes.
How would you consider a shape as a square? What do you think in the diagram that we have here? How would we consider something as a square?
Yes. How will you consider a shape as a square?
So we can use the instrument like a ruler.
Yeah.
By considering widths and the lengths. If we go to the same size, suppose width it has 2 centimeters and the length it is 2 centimeters, we can say this one is a square.
Okay, thank you so much. I'm sorry, I didn't get your name.
From Aquinas, HP 15.
Oh, thank you.
Aquinas Secondary School.
Okay.
But I forget to register.
All right, nice. Thank you so much. So HP is giving us a reason for knowing if a shape is a square, that you can take a ruler and measure the width and the length. And if the width and the length are equal, that means it's a square. Another person with a different idea. What about for example, we are having here 5 by 5 square grid. So how will you consider squares in this square grid? Without measuring, how will you consider?
But I think for that 5 by 5,
yes,
we can measure only one full square.
Yeah.
If we determine that the length and the width is the same,
yeah,
that means even other full squares is the same.
Wow. Thank you so much, HP. Thank you so much. HP is also giving us again the explanation for observing the square, for knowing an object given is a square. Yes, thank you so much. So how many numbers of squares do we have in this 5 by 5 square grid? So we can, sorry? Go on, please.
We have exactly 25 full squares.
Yeah.
Yes.
Can you give us the explanation to your answer, please?
The explanation is that the length and the width of all the squares are the same.
So you're saying the length is 5 and the width is 5.
If we can measure, for example, if you can take a ruler,
yep,
then you try to measure the length and the width of a square.
Yeah.
It seems to correspond to each square, and therefore these squares are seen to be similar, which means they have the same size. So if they have the same size, we should have to take the column and multiply with the number of the squares of the load. So we take the number of the squares from the column, we multiply with the number of the squares from the row. Then we obtain the total number of squares.
Okay, thank you so much. So you said
I think we've lost audio.
oh, sorry. Okay, so can we find the pattern? Can you see the pattern, or can you find the pattern to counting the number of squares in a grid? Anyone?
Repeat your question.
Sorry?
Can you repeat your question?
Yeah, it's a question. Can we find the pattern to counting the number of squares in this square grid?
So to find the number of square,
Yes.
it depends on the nature of the figure. We have a formula to find the number of that square. We can take half square plus whole square.
Yep.
Half square plus whole square, we can get the total number of whole square. But for this one, we have only whole square.
So you're saying you have a formula to getting the number of squares in any given size of a square grid. And you're saying the formula is a half squared plus 4 squared. So this is the formula for all the square, any size of a square, or for only this one?
It depends on the nature of the figure.
So like this one, you're having 5 by 5 square grid. So you're saying the formula is?
But for this one, we can only take 5 times 5.
So for this one, you're saying the formula you can only take 5 by 5. That means you are timesing the number of columns and the number of rows, right?
Yeah.
Okay, good. Thank you so much. Any person with a different pattern to finding the number of squares in this square grid?
What if we come up with a pattern where we can account for all the squares and make sure that we have counted all of them, and we are sure with the total number of the squares that we get
in any given square grid?
Or say, for example, just in this 5 by 5, what if we just come up with a way of counting the squares in here, such that we are sure that we have accounted for all of the squares?
I think for this one,
yeah,
I think let you come back to somewhere. Counting all squares.
Yes.
It is just a wastage of time. Because when you have a lot of squares, suppose you have 500 squares, how do you count it? So it is better to take it horizontal times vertical. We can get that is a simple method.
Wow, good. HP saying that counting the number of squares will be hectic. So he's saying it's the better way is to take the number of the columns and the rows, then you multiply. So that is the pattern that he came up with. Any person with different pattern or different way of coming up with the pattern to counting the number of squares in this 5 by 5?
Let us try count just one by one and see if we could try and come up with a pattern that saves time, now that it might be tiresome, like you suggested.
Good, thank you.
Let's try.
Good. So let's see how we can calculate the number of squares in 5 by 5, this one, square grid, one at a time. So for example, This one, it's a 5 by 5 squares. Let's count one at a time. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and 25. That is only for 1 by 1 square. 1 by 1. It's a total of 25. Let's see 2 by 2. Since we are counting one at a time, 2 by 2 will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. A total of 16 squares for 2 by 2. Then let's see for 3 by 3 squares. 1, 2, 3, 4, 5, 6, 7, 8, 9. We have a total of 9 squares for 3 by 3 squares. Then let's see for 4 by 4. 1, 2, 3, 4. It's a total of 4 squares for 4 by 4. Then for 5 by 5, it is only 1. This is the biggest square. So we have the biggest square for 5 by 5, which is 1. And we have the smallest square for 4 by 4, there are 4. And we also have 3 by 3 squares, there are 9. We have 2 by 2 squares, there are 16. And then we have 1 by 1 squares, there are 25. Then let's see the total. You add 25 plus 16 plus 9 plus 4 plus 1. As Janet has said, that you're having more than 25 squares in a 5 by 5 squares. He said that they are biggest square. This is a biggest square, which is 5 by 5, which is 1. Then we have 1 by 1 square. 1 by 1 squares, there are many, many smaller squares in a 5 by 5 squares, and they are 25. Then we have 2 by 2 squares, which are 16. We have 3 by 3 squares, they are 9. 4 by 4 squares, they are 4. And the largest square, 5 by 5, 1. Then the total of 55 squares.
I have a question.
Any question? Yes, yes.
Now you get the 5.
Yeah.
What is the exact answer? Is it 25 or 16 or 9 or 4 or 1? Now, what is the exact answer?
The exact answer of the number of squares in 5 by 5 square is 55 squares. As Janet has said, that we have 25 squares for smaller squares. 1 by 1, they are 25. Then we have 2 by 2 squares, which are 16. Then we have 3 by 3 squares, they are 9. And we have 4 by 4 squares, they are 4. Then the largest one, which is 5 by 5, is 1 square. Then you add them together and you have the total number of squares in 5 by 5 squares to be 55 squares.
But maybe you need to specify that answers.
So 25 is only for smaller squares, the 1 by 1.
I have a question.
Yes,
please go ahead.
As he was writing more than what you are speaking. So can you repeat it? Can you prove if there are 3?
Oh, thank you. So yeah, let's start again.
So while she starts, you remember, like you had suggested before that for a figure or a shape to qualify as a square, both sides have to be equal. So we are trying to look for the number of shapes or the number of shapes that qualify as square.
A square.
That have both sides equal. And then we are just trying to come up with a way of counting them so that we do not miss any of them. So the way that she used to count them is by considering the smaller ones as we progress to the bigger ones. So let us repeat again.
Good. So here we are starting with, sorry?
Sorry, I felt the explanation there.
Yeah?
If we say you have to catch every square, what about the one that appear more than one?
Like I asked before, if we come up with a pattern, say for example, the pattern that Fleria has used is to count the smaller ones, then go ahead to as we progress to the bigger ones. So we identify the squares according to the size, their sizes. So the squares that both sides are equal to 1, the squares that both sides are equal to 2, the squares that both sides are equal to 3, and the squares that both sides are equal to 4, and squares that both sides are equal to 5, without repeating and making sure that we do not leave any. So that is why we are doing that. We are making sure that we do not repeat any, and we are making sure that we do not leave any of them.
Good. So we are starting with the smaller ones, 1 by 1 squared, because in the upper, it's only 1 squared. So it is 1, starting with the first one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. And there are 25 smaller squares for 1 by 1 square. Because we said a square is a figure that has the same length and the same width its size. So for the smallest size 1, it's only 1. So you count how many squares they are there. The 1 by 1 squares, there are 25. Then we go to 2 by 2. Because in the width you are having 2 squares, and in the length also you are having 2 squares. So you count the 2 by 2 squares. It will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we are having total number of 16 squares for 2 by 2 squares. Then we go for 3 by 3 squares. The number of width is 3 squares, and also the number of length is 3 squares. Then we count how many are there in total. So you're having 1, 2, 3, 4, 5, 6, 7, 8, and 9. We have total of 9 squares for 3 by 3 square. Then we go to 4 by 4. You have 1, 2, 3, 4. There are 4 squares for 4 by 4 squares. Then lastly, for the 5 square, for the 5 by 5 square, we are only having 1, because in the length we are having 5, and in the width we are having 5. So it's only making a full square of 1. Then you go on and add for 1 by 1, which is 25, for 2 by 2, which is 16, for 3 by 3, which is 9, for 4 by 4, which is 4, and then lastly for 5 by 5, the bigger square, which is 1, and you get 55 squares in total.
Anyone with a question before we look at this further? Anyone with a question?
I have a question.
Yes, please go ahead.
For
small square 25, I understood, but for 16, I did not understand. Because when you count 2 by 2, that means you consider four small squares, is it?
Yeah.
Did you consider 4 small squares as 1?
Yes, we consider that we started with 1 by 1 squares in 5 by 5 squares. We started with 1 by 1.
I think that is a very exciting question that we should look at. What do you think? Just from the question, what do you think? Do you think that there is a square left out, or there is a square repeated?
There is a square repeated.
Let us have a look at that. So, for example, you are looking at a 4 by 4. Was that the question, or a 2 by 2?
A 2 by 2.
Yeah. So, which square do you think? It was a 4 by 4. Okay.
The first one we get 25, and the next is 16. So to me, when I take 2 by 2, I get only 8, not 16.
Oh, okay. Oh, so when you try counting 2 by 2, you only get 8 of them.
I can get only 8, not 16.
So let us go back to the formula that we or the pattern that you said before. Considering that we are looking at shapes that have equal number of sides and equal number of just equal number of sides, and we are splitting them so that we are focusing on 1 by 1, 2 by 2, 3 by 3, 4 by 4, and then by 5 by 5. So yeah.
Sorry? Maybe we did not understand it.
Yes.
Okay. When you count 2 by 2, that means you can take 4 as 1, is it?
Yeah, yes,
sorry?
Yeah.
Did you take 4 small square as 1 when you count 2 by 2?
So in a case where we take 4 small squares by 1, we consider that it is a 2 by 2 square.
Now
And we consider that the length is 2 and the width is 2. So we consider it as a 2 by 2. We no longer consider it as small squares.
2 by 2, that means we have 4 centimeters and then we have 4 centimeters.
In a 2 by 2, say for example, in a 1 by 1, we are using 1 as the unit here. So in a 1 by 1, we have 1 unit by 1 unit. So in a 2 by 2, we will have 2 units by 2 units.
That means 2 squares in the upper and also in the first row, and also 2 squares in the first column.
Okay, now I understand you, but we make it repetition of counting.
Good.
I think our time is up, but just to summarize on this, well, what you are considering as being repetitive, do you think it is a way of being systematic in counting so that we do not leave any squares not considered? And do you think just by having a plan, or just have a look at this? Have a look at this. If we divide the squares in such a way that we have a square that is represented on the left and a square that is represented on the right. The square represented on the left is just a unit by a unit, and the square represented on the right is 2 units by 2 units. And if we proceed, the square on the left here is 3 units by 3 units, and the square on the right here is 4 units by 4 units. But if we have a square like this, do you think there is no way that we could be systematic to capture all the squares in such a way that 1 unit by 1 unit, 2 unit by 2 unit, 3 unit by 3 unit, and the 4 unit by 4 units, and the 5 unit by 5 unit, that makes the smaller squares are captured so that we have the total number of squares in this? Do you think we can be systematic and do that so that we can be able to find the number of squares in, say, for example, a 50 by 50 square? Do you think that is possible? Our time is up, and I think we will have to leave this as a way of an extension to this problem. So what I am showing here is a 5 by 5, and if I add another one, we will have a 6 by 6. And this now doesn't total to 55, but this one now is totaling to 91. Do you think we can work on a way to come up with a formula where we can get the number of squares in a square that is bigger than this? Say, for example, the one that we started with before, a 10 by 10. We could look at that, and if anyone has a question, please just feel free to share in the WhatsApp group. Okay. Let me know if anyone has a question before we finish. Our time is up, and sorry for going past the time. Anyone with a question?
Thank you. I have a question for the group. Do you think this is a good activity to do with students?
Yeah, you can unmute yourself and talk.
Yeah, it is a good activity for the student.
Great. It will be interesting if you try this out and try it with the students as well. And then there are so many ways you can do this. And while you think about the formula of how you can calculate the number of squares, the total number of squares in an say, for example, an n-sided by an n-sided, a square, for example, that looks like this. What if we have a square that looks like this? It will be tiresome to count all of them. So do you think you can come up with a formula to do this? And how can you just like Janet has asked, how can you incorporate this in your lesson planning and do this with your students? And what if you have a case where you have squares that are slanting? So this activity can be accessed from the link that I've just shared here, and I'm also sharing it in the chat.
Yeah.
And it has an explanation and an extension for this activity that you can do with your students. further?
Some maybe you can share it also on WhatsApp group.
Yes. Is there anyone else with a question before we finish? So we can continue with this discussion in the WhatsApp group, and feel free to give your ideas or any question, and we will respond to them. Thank you so much for creating time and joining today's session. And we hope that you find this useful in your lesson planning, as well as in your collection of games and puzzles that you are using in the teaching and learning of mathematics. Thank you.
Thank you.
Thank you so much for your time. Thank you.